Hello, so this screencast is for my distance-only students. You're going to see the what was kept constant and what can you change, as well as the time and displacement values. These are what we were able to measure and record from the experiment that you saw before. So I gave here our procedure, the steps, what we did. We gave just a little push to get that little roller, also aka me, to get that to start. After 2 seconds, we made a mark on the pipe to show where the front of the roller was at that time. Every 2 seconds, made a mark. And then we measured the total distance traveled over the time, which is its displacement. So we record that displacement data. So what you're going to need to do is create a copy of this spreadsheet. When you make a copy of that, then you're going to be able to copy all this right here. I'm copying from the 0 down. Control C to copy. And then I'm going to click on the 0, and then it's going to paste everything below it. So Control V, and I also make sure I put in my 0 value as well. So once I paste that in, then you can see the displacement values show up and with the corresponding time. And what we have over here in the velocity is the velocity, even in the equation, shows the change in the distance over the change in time. So that's what this equation here is showing. So it's showing that we took the change in the displacement values, so it's change in displacement over change in time. And that is how we are able to get to these values. So we need to do two things. Copy our data table. As we copy the data table, you copy the data table and then you paste it in over here. I'm going to try to attempt one more time, and then it will do it for us. Control C and Control V, and now you have your velocity data as well. So then you take your graphs, you need to paste in your graphs. The way you paste in your graphs is you click on this graph and you click on the top right to copy the chart, and you paste this. We want to paste it unlinked. Do it for both the displacement as well as the velocity graph. So to get the velocity graph, you copy that chart, paste it unlinked. So we see there's a relationship here, a linear relationship for the velocity versus time, and a nonlinear relationship here for the displacement versus time. On the linear relationship, we also have this slope, 2.75 times 10 to the negative 3. Now the slope of this is the acceleration. So we have the acceleration value on of this little roller. So what you need to do as you look into the analysis is you need to expand upon what the slope is. So I gave us the slope for graph number 1. The slope is your velocity. The slope for a velocity versus time graph is acceleration. I want you to expand upon it and use unit analysis to also help solidify what you're saying here in this answer. In graph number 1, the bigger the acceleration is in graph number 1, the more curvy it will look. The bigger the acceleration in graph number 2, it's still going to have a linear relationship, but it will be a greater change in that velocity. So from graph number 2, we're able to derive this equation from a linear relationship of y equals mx plus b. Y-axis is velocity. M, which is the slope, is our acceleration. X, which is our x-axis, now is our time. So y equals mx plus b, velocity equals acceleration times time, plus that initial velocity. This right here just tries to give us some insight into how we derive this displacement equation, this x equal to 1/2 at squared. This is a displacement equation. So this is how you're able to derive it. All we're doing is we're calculating the area underneath a velocity versus time graph. That's how you get displacement. Base times height is going to give us then that area, and that area will tell us the displacement. So then in the CER, I gave us some sentence starters, but I want you to try even recognize further. that the position here, it increases exponentially. And from that, we know that the position versus time graph appears to be nonlinear and exponential. And so since it has that behavior, I need you to finish that statement saying that you know that the change in position with respect to time will be something. Further, state then the slope of your velocity versus time graph. So there is a slope. That was this 2.75 times 10 to the negative 3 meters per second squared. And then what does that tell us? You need to go in more and tell us what does that mean and relate this back to the position. And then lastly, we have this displacement equation, x equals to 1/2 at squared plus v naught times t plus x naught. And we found that by finding the area underneath the velocity versus time graph. So if we just use the area and we calculate the area, we get the area to tell us that it's about 0.36 meters. If you use the slope of the velocity versus time graph as this acceleration within this equation, then for the same time frame, it's calculated to be about 0.35 meters. So those values are close enough to argue that we have found the relationship of displacement versus time. Once you're done with this, go ahead and turn in this laboratory experiment. Thank you.